Hello, everybody. Now we're going to start the last part in the three-part series. And we ended the last video in the top left screen here, and we're basically SSH'd into the machine. Everything's staged as far as what we're going to need for this tutorial. And the first one we're going to walk through is basically running a LandDA container. So we're going to take the infrastructure we've created, and we're going to run a very easy-to-use container for LandDA, and then we'll have a separate series that'll focus on SRW. So let's get started. All the links and code will be attached in the tutorial below, and it'll kind of accompany the user's guide, as well as we'll kind of talk about the data and some of the other files we're going to utilize. Okay, so first let's get started. So we already have the Intel compiler on here. So I like this example because even if we use like a C6i image, which is AWS's term for Intel pre-installed. Because we use spack-stack and we already have that installed on there, there is an Intel compiler pre-installed on that, so we'll actually utilize that. So we can basically run this on any machine. So I will go module use spack-stack Linux star, and then I'm going to say modules available to see which ones are available. And as you can see, we have the Intel compiler and the Intel MPI. So we're going to go ahead and load those. So I'm going to load Intel compiler and Intel MPI. Great. Okay, now we're going to make kind of a staged or a scratch directory. It's nothing more than just a working directory that we can work out of. So first, I'm going to make a directory called Luster. And then I'm going to change the permissions, so sudo chmod 777 luster, which is simply making it open so that I can install anything I want on there. And then I'm going to cd into that directory. Okay. From here, I'm going to make another directory called LandDA. I'm also going to change the permissions of that. And then I'm going to cd into that directory. Okay, and we should have nothing in there. There we go. Okay, so we're going to make this kind of our export directory. So this is going to be our root directory. And this is going to be the directory that we basically are going to pretty much do everything out of. We're going to build our image here. We're going to stage our data. And then we'll kind of do it all of this LandDA directory. Again, this is kind of our working directory. So first thing I'm going to do is stage the data. And I'll kind of talk to you about this as it maybe takes a minute or two to download. So I did wget, and then we have the data staged here. So it's in their NOAA UFS LandDA PDS directory. So if I go here just to the root, as you can see, I'm basically just going to the pds.s3.amazonaws.com. We also have prior releases, right? So if we are downloading the current one or version 1.2.0, but we also have in here version 1.0.0 and 1.1.0. You can download the input directory, the input files. You can also go ahead and just download the images from here. So by adding the version right in the URL, you can kind of go through here and get the exact data you're looking for. So again, in this case, if you come through here, you can see that we're using the version 1.2, and then we're going to use this LandDA version 1.2.0 input data. And we're going to kind of build the image a little bit differently, but the image is also saved here in S3. So if you'd prefer, you can just kind of download it directly right from there, and it could just save you a little time. But we're going to kind of install it from root so that it could be kind of utilized a little bit easier. So also, as we're going through this, we have about another minute and a half here. So there's the follow-on here is the containerized LandDA workflow. A lot of this is kind of geared toward tier 1 systems. We have this set up in a pretty similar way. So kind of as an example, you can see where they have, some temp directories. We have what we call our root directory. So kind of just a slight modification there. And then once we go to build the container, you can see a lot of the commands are going to be the same. They kind of made a directory called LandDA, and then you're going to export LandDA root, which is kind of what we've already done. And then after that, you're going to build the image, and then we're just not going to call out a specific machine. So again, very similar, but not quite exact. And you can kind of look at this this cheat sheet of running commands in verbatim, and it'll kind of make it a little bit easier instead of working on a tier 1 machine. So we have about 40 seconds left. Then we're going to go ahead and untar the data, and then we're going to basically set this input directory that we're going to look at, and then we're going to kind of pause once we get to the building the container. So we're going to singularity build the container, and that'll take about 15 minutes to fully create an image file. So we will pause at that point and then pick up the video. So know that that'll be kind of the only stoppage in the video. Okay, we're pretty much done here. So we're going to tar xvfz, and that's basically just going to untar the data file, and it'll stage it right here in our directory. So so here we go. So yeah, so there's quite a few different input files it's going to create, and we're just going to set our input as Lustre LandDA import, and again we'll then kick off the container, and then we'll just pause the video really shortly. So this will take probably just about another 30 seconds to expand all of these files and untar them, and then we will go ahead and build the container. Okay, should be just about done. And then again, as soon as this is done, we're going to export the variable for LandDA root, for LandDA input, and then we're going to build the container. Okay, so there we go. We're complete. And as you can see, then there's an input directory there. So we will set the LandDA input directory as Lustre LandDA inputs. And then the next one is to build a container. So it's singularity build, and we're going to force building of an image, and we're going to pull it from Docker, and it's the current public release, which is version 1.2.0. So I will kick off a singularity build, and as you can see, it's probably about 12.5 gigs. So it'll take about 15 minutes from the time that it downloads and then creates an image file for that. So this is a good place to pause the video, and then once we come back, we'll go ahead and export the image, and we'll kind of finish kicking off the workflow, and then we'll kind of show some examples of the output. Okay, and now we are back, and as you can see, it created the CIF file. So if I do an ls, as I just did, you can see that there is now the Ubuntu image for LandDA that's currently there. Okay, so now we're going to tell the system where the image is located. So we're going to export the environment variable for image, and it's under Lustre LandDA, and it's the Intel LandDA image. So now we're going to basically pull the workflow out of the container, and we're going to stage it locally on our machine. and then we're going to set another couple environment variables, and then we're basically all set to kick off the workflow at that point. So the next command is going to be singularity execute, and it's within Lustre of the image, and then we're basically going to pull out the workflow. So this will take just a second. Okay, all right, so as you can see, it pulled the workflow out. So if I do an ls here, the workflow is now outside of the container, and it's something that we can now use to run. So I'm going to now set cd into the LandDA workflow. It's just a good idea to test the LandDA root every once in a while, so this should take us in, and it does. And then we're going to export another change. So again, we talked earlier about a lot of the tier 1 systems being supported. One modification is baseline. So the baseline environment variable is really usually set at like hera.internal or something, but we're going to use singularity to run this. So we are going to change the environment variable for baseline to be singularity.intel. So let's go ahead and change that one. So now we're actually ready to go ahead and submit a job. And then as it submits, let me just check this real quick. Okay, we're all set there. As it commits the job, we're basically going to kind of talk about some of what's going on. So it's important to understand costs. So right now we're in our head node. It's a C5 2XL. It's about 34 cents an hour that it runs. And this really won't take that long to run. We're going to, in a second, kick off a compute node that runs a little over $3 an hour. So it's really important that you manage these resources. If something gets hung, and like a compute node, sits up for a couple weeks, that can be really expensive, right? So these will spin up and tear down themselves. But if for some reason anything happens, you can always come in here, click on the checkbox, go to instance state, and you can either stop or terminate either. If you stop it, it'll bring it down. Then you can always start it back up again later. The compute nodes, you can usually just go ahead and terminate if they're hung. The head node, it's a better practice to start and stop those, since that's kind of where everything is staged. So with that, we're going to send a job. Okay. It submitted a batch job, so you can see that it successfully found everything and started kicking off our first job. So it's going to, in about a minute here, it'll start spinning up a compute node. In the meantime, we're going to cd back just one directory. So you can see once we kicked off our job, it's creating both a working directory and a LandDA export directory. Okay, yeah, so it's already spun up our compute node here, and this is actually a really pretty quick job, so it should kind of finish and spin down fairly quickly. The LandDA application is fairly lightweight, so I'm going to go into the LandDA export directory, and a successful run, just as it says in the documentation, you'll basically see files within the restart and then the vector directory. So I'll go ahead in here, I'll cd into restarts, and now I will cd into vectors, and then I'll do an ls, and then sure enough we have netcdf files that are starting to be created. So that's it. You'll kind of it'll finish its job and tear on down. And then again, if it doesn't for some reason, you can go ahead and click on the compute node. You can go to instance state and you can terminate the instance so you don't incur those costs. And that is on a per hour basis. So if it, kicks a job off in 10 minutes and then spins back down, it'll maybe only cost like 20 or 30 cents. So we are pretty optimized as far as managing costs to do some of these lighter jobs, but it's really important just to understand costs in the cloud and how important they are, and we'll probably have a separate series on that. So with that is how you can go from having a completely green AWS account to running one of our UFS applications in the cloud, and we will have subsequent videos. So thanks for your time.